Hello everyone, this is Nikhil, Assistant Professor Department of Civil Engineering, AICTE Bangalore. So today I am doing this video to explain about losses in prestress. So what is losses in prestress and why we need to know the amount of loss in prestress? So here in prestressed concrete, the most important parameter is prestressing force. If the prestressing force reduces with time, then prestress also get reduced. Hence, at the time of transfer of prestress to the concrete member, there is a drop of prestressing force from recorded value which is given in the jack gauges or as per the design. So there are various factors which have influence on the reduction of this prestressing force, and the reduction of this prestressing force is called as losses in prestress. So here losses can be categorized into two categories. One is immediate loss and time dependent loss. So immediate loss means we know it will occur within a shorter span. So time dependent means it will take some time to occur. So here the immediate losses are elastic shortening, friction, anchorage slippage, and time dependent. That is long term loss. The loss which will occur in after a long term is creep, shrinkage, and relaxation of steel. So now let us see one by one what is elastic shortening, what is friction, what is anchorage slip, what is creep, what is shrinkage and relaxation of steel. So before that, let us see what are the different types of losses that will occur in pre-tensioning member and post-tensioning member. So you all know what is a pre-tensioning member and what is a post-tensioning member. So you have studied this in your module 1. So pre-tensioning member means here the steel is tensioned and then the concrete is placed. That is pre-tensioning. Whereas in post-tensioning, the concrete is placed and a provision is made to pass the steel. So the provision is made in the form of ducts or voids, and the cables or steel is made to pass through this ducts, and then it is tensioned and anchored. So what are all the losses that will occur in pre-tensioning and post-tensioning? So first loss in pre-tensioning is elastic deformation of concrete. Similarly, in post-tensioning, there is no loss due to elastic deformation of concrete if all the wires are simultaneously tensioned. So if the wires are successfully tensioned, then there will be loss in pre-stress due to elastic deformation of concrete. So in the next slide, I will tell you what is elastic deformation. So before that, let us see different types of losses in different tensioning members. So creep of concrete. So in pre-tensioning member, there is a loss of pre-stress due to creep of concrete. Similarly, there is loss of pre-stress in post-tensioning member also due to creep of concrete. So in pre-tensioning member, the loss also occurs due to shrinkage of concrete. Also, the loss is occurring in post-tensioning member due to shrinkage of concrete. Similarly, there is a loss due to relaxation of steel in both the cases. And when we come to pre-tensioning member, the loss of pre-stress due to anchorage slip is zero, whereas the loss due to anchorage slip occurs only in post-tensioning members. Similarly, in pre-tension members, the loss due to friction is zero, and the friction loss occurs only in post-tensioning members. So now let us see what are the different types of losses and how the losses will occur, and how these losses can be calculated and how to encounter the losses. So different types of losses in pre-stress. So there are 6 losses which will occur in pre-stressing of concrete. So first one is loss due to elastic deformation of concrete. Second one is loss due to creep strain in concrete. Third one is loss due to shrinkage of concrete. Fourth one is loss due to relaxation of steel, loss due to anchorage slip, and loss due to friction. Yes. So here we should keep in mind one thing, that is the total loss. The total loss which is occurring from all these losses should be between 50 to 20%. If it is more than 15 or if it is more than 20%, then the member is not suitable for construction. So first let us see what is loss due to elastic deformation. Here, when the prestress is applied to the concrete, an elastic shortening of concrete takes place. As the concrete shortens, the tendon length also equally shortens, resulting in loss of prestress. So here you can see this tendon. It is a free tendon which is placed before a concrete is casted. So here the tendon is tensioned. So tendon is tensioned and then the concrete is placed. So what happens here, when the tendon is tensioned and it is anchored at its both the ends, the tendon will be having a tendency to regain its original shape and size. So at this condition, when the concrete is placed on this tendon, so the first, this one shows a free tendon and this shows a tendon to which the stress or to which the pre-stressing force is applied, and this shows a member which is constructed with the concrete, and the last one shows elastic shortening of a concrete. So here what happens, after applying a concrete for tensioned member and when it is anchored at both the ends, so after applying a concrete, both the ends, this end and this end, is anchoraged using wedges. So there are different methods for anchoraging. So using any one of the method, both the ends are anchoraged. So this end and this end are anchoraged through wedges. So when this is done, the cable or tendon is already in tension, so the tendon will try to regain its original shape and size, so that the stresses are developed on both the ends of a concrete. So the tension or stresses is developed on this end as well as this end. So as a result of this stress developed on both the ends, the concrete will reduce its length. That is, the concrete will undergo a shortening. So when the concrete undergoes shortening, the tendon which is tensioned will also reduces its length, and hence there is a reduction in the pre-stressing force. So in this image we can see elastic shortening of a concrete. So there is a shortening of a concrete for this length of this length L or X. So the length of tendon is also reduced by that length, which reduces the effective pre-stressing force. So here the effect of elastic shortening varies along the length of the tendon, whereas in simply supported beam, the midspan section is the critical section for flexural stresses. So if I consider a simply supported beam, in a simply supported beam, the self weight of a member will be always a UDL. So when these members are subjected for a uniformly distributed load, the maximum bending moment will occur at midspan. So that is, the midspan section is critical section for flexural stresses. That is, the bending stresses will occur at the midspan, and hence the pre-stress loss are considered at the midspan section. Whereas if we consider the continuous span, due to different conditions of loading, there may be several bending sections. That is, that we may get a many number of flexural critical sections along the span. Hence, it may be possible, or it may not be possible to adjust the stresses in the tendon to eliminate the reduction of pre-stressing force due to elastic shortening. And here, for pre-tensioning, the elastic shortening is due to the net initial concurrent stress that results from the algebraic sum of stresses due to initial pre-stressing force. Whereas in post-tensioning, if there is a jacking of cables, or if all the cables are anchored at a time, the losses will be zero. If the cables are anchored one after the other, then there will be losses in the pre-stress. So here the maximum loss will occur when the first cable is pulled and anchored, and the minimum loss, or the loss of pre-stress, will be zero when we pull and anchor the last cable. So here you can see the formula to calculate loss due to elastic deformation of concrete. So we can use the formula delta Fs is equal to mfc, where m is nothing but it's a modular ratio which is given by ES by EC, where ES is Young's modulus of steel and EC is Young's modulus of concrete, and FC is the compressive stress in steel at the level of CG of a steel, and it can be calculated using a formula FC is equal to P by A plus PEY by I, where P is the pre-stressing force, A is the cross-section area of a member, P is again pre-stressing force, E is the eccentricity of a cable with respect to the CG, Y is centroidal distance with respect to top fiber, and I is moment of inertia. So MFC is the formula which we can use to calculate the losses due to elastic shortening or elastic deformation in case of post-tensioning members. Whereas in case of M so we can calculate loss of elastic deformation, loss due to elastic deformation from the equation delta Fs is equal to mFc. So that is for the pre-tension members. Whereas for post-tension members, as I told you, when all the wires are pulled simultaneously and anchored, the losses are zero. When the cables are pre-stressed, or when the cables are pulled successively, that is one after the other, then the losses in the first cable will be maximum, and the losses when the last cable is pulled and anchored, it will be zero. Because here you can see in this picture, in the third picture, let us consider the first cable is pulled and it is anchored. So when the first cable is pulled and when it is anchored, the cable exerts tension on both the ends of a concrete, on both the faces of both the ends of a concrete, and hence the allowable shortening of a concrete will take place. And then if the second cable is tensioned, then there may be some more provision for the shortening of concrete, so that will get altered. Whereas by the time we reach the last cable, the elastic property of the concrete will be fully saturated, and the elastic shortening or elastic deformation of the concrete will be zero. And hence, when the cables are pulled successfully, the losses will be zero for the last cable, and the losses will be maximum for the first cable. And now coming to the second loss due to creep in concrete. So what is creep? So creep means, this you have studied in your concrete technology in your second year. So creep means it is a permanent deformation of a concrete member. So permanent deformation means it cannot regain its original shape and size. So why the concrete will undergo a permanent deformation. So here, when the concrete is subjected to constant stresses or constant loading, the member will undergo irrecoverable deformation. That is, it will undergo permanent deformation. So this happens because of the flow condition of a concrete, and this permanent deformation is called as creep of concrete, and the losses which occurs due to this permanent deformation is called as loss due to creep strain in concrete. So here, in case of pre-stressed concrete structures, concrete remains under the action of continuously acting thrust due to the presence of tensioned steel. Under the action of this thrust, concrete undergoes permanent deformation because of constant tension, which gives rise to the permanent deformation of a concrete. So creep of concrete depends upon the intensity of stresses, and it also depends upon the transfer of pre-stress, cement content in the concrete, density of concrete, water cement ratio, atmospheric condition, and temperature. So these are the factors which influence the permanent deformation of a concrete or creep of a concrete. So how to calculate creep of a concrete and how to encounter the loss? So here, the loss of pre-stress in steel due to creep of concrete is calculated by the formula phi MFC, where phi is creep coefficient, which we will get from IS 1343 1980. So for different ages of a concrete, we have different creep ratio, and epsilon C is a creep strain in concrete, epsilon E is elastic strain in concrete, M is modular ratio, which we can calculate by ES by EC, FC is stresses in concrete, which can be calculated by the formula P by A plus PE I by I. EC is modulus of elasticity of concrete, ES is modulus of elasticity of steel. So here, the creep loss in concrete can be calculated in two ways. One is when a creep coefficient is considered, the formula is phi MFC. When ultimate creep strain method is followed, or when we consider the ultimate creep strain method, the loss of pre-stress in steel due to creep of concrete is equal to epsilon C FC into ES, whereas epsilon C is ultimate creep strain for sustained unit stresses, FC is again stresses in concrete, and ES is modulus of elasticity of a steel. So using this formula, we can calculate what is loss in the pre-stress of steel due to creep of concrete. So next let us see what is loss due to shrinkage of concrete. So shrinkage means it is a deformation. So shrinkage is the deformation of member which occurs without external applied stresses. So we are not going to apply any external stresses, or we are not going to apply any external load, but the member is undergoing deformation. So why it will undergo deformation? That is, the shrinkage of concrete in pre-stressed members results in shortening of tensioned wires and ends contribute to the loss of stresses. So here we can tell that shrinkage is defined as contraction of concrete which occurs due to loss of moisture or loss of water content during the process of hardening of concrete. So the loss of moisture occurs during the hardening process of a concrete due to heat of hydration. Therefore, we can tell that the factors influencing the shrinkage of concrete are water content, water cement ratio, atmospheric condition, and type of aggregates used. As the water cement ratio increases, shrinkage of concrete also increases. Shrinkage increases is not whether shrinkage of concrete also increases in hot weather than cold weather. So when we use lightweight concrete, then there is increase in the shrinkage of concrete. So contraction of concrete due to shrinkage gives rise to equal contraction of the tension in steel. So whenever the concrete shrinks, that is whenever the length of a concrete member decreases or reduces, similarly simultaneously the length of tensioned steel reduces. Therefore, there is a loss of prestressing force which is applied to the steel. So the loss of prestress in steel due to shrinkage of concrete can be calculated by the equation epsilon Sh into Es, where shrinkage strain for prestressing of pre-tensioned members ESH is equal to 0.0003, and for post-tensioning members ESH is equal to 0.0002 divided by log 10 into T plus 2, where T is the age of concrete at 28 days and ES is the Young's modulus of steel. Now let us come to the next type of loss, that is loss due to relaxation of steel. So what is relaxation? When high tensile steel is kept under tension for a long time due to loss of elastic property of the wire or a steel, the initial pre-stressing force does not remain constant. So whenever the steel is held at constant length in a tensioned state, it loses its pre-stress with passage of time, and this phenomenon is known as relaxation of steel. So the relaxation of steel depends upon various factors such as intensity of stress, duration of stress, and type of steel used. As the intensity of stress increases, loss of pre-stress due to relaxation of steel will also increase. And here we should note that the duration of stress increases, the age of structure will increase. Loss of stress due to relaxation of steel is also increased. Relaxation loss will be more for ordinary steel compared to high strength steel. So the value of relaxation of steel varies with type of steel, initial prestress, age and temperature. The loss of prestress in steel can be calculated using the formula delta Fs is equal to Kfc by 100, where K is prestressing loss due to relaxation and F is initial prestress. So the next loss is loss due to anchorage slip. So anchorage slip means, so see here, in this, here the steel or a tendon is tensioned in the first stage, and in the second stage the tensioned steel is held on both the ends of a the bed which is constructed in the site, and then the concrete is placed above this tensioned steel. So after placing the concrete, this tension steel is anchored on both the ends of the concrete. It is anchored on both the ends, here and here. So what happens when it is anchored on both the ends, or what will happen during the anchoraging of the tendons? So it is a common practice when we try to anchorage, or when we try to tighten some screw or nut, there is a chances of slippage, right? So So even we have experienced that in our daily life when we try to tight some screw or nut, there will be some slippages or there will be some missing of the threads. So due to this slippage, while tightening or while anchoring, there is a loss of prestress. So this loss occurs only in post-tensioned members, because in post-tension members, first the concrete is casted, the concrete member is casted and it is allowed to gain its strength, and then the cables are passed through the ducts which is foddered into the concrete, and then it is anchored. So while anchoring this post tensioned members, there may be slippage of the anchoring system. So due to this slippage, there is a loss of pre-stressing force. So in the post-tension system, when the cable is tensioned and the jack is released to transfer pre-stress to the concrete, the friction wedges which are used to grip the wires slips over a small distance before the wires are firmly housed between the wedges. So the loss due to this anchorage slippage can be calculated using the formula AE by L2, or we can also, so the loss of pre-stress in steel due to anchorage can be calculated using the equation S is equal to delta ES by L, where delta is the amount of anchorage slip in millimeters, L is the length of cable in millimeters, and ES is modulus of elasticity of steel which is used in the construction, and it is in the terms of Newton per millimeter square. Now coming to the last loss due to friction. So we all know what is friction. So friction means it is so we all know what is. Now let us come to the next type of loss, that is loss due to friction. So when the friction is built up, when two members come in contact, the friction is developed. So when the two members come in contact and due to the friction, there is a loss of pre-stress in the cable or a tendon. So in case of post-tension members, the tendons are housed in the ducts performed in concrete. The ducts are either straight or it may be curved depending upon the design requirements. Yes. So this friction loss will occur only in post-tension members. So the post-tension members, the concrete will be already casted, and for the passage of these cables, the ducts are inserted in the concrete during the construction. So the ducts may be straight or it may be curved depending upon the requirement. So the cables or tendons are allowed to pass through these ducts. So here you can see in this figure. So here there is a rectangular member, and here we can see a duct. If we consider this as a duct, and the cable is made to pass through this duct, and the duct is a curved duct. So when a cable is passed through this duct, what will happen? At this point and this point, the cable will come in contact with the surface of the duct. So when these cables or tendons come in contact with the duct, there is a loss, and this loss is called as friction loss. So this loss arises only in case of post-tensioning members due to the relative motion between tendon and the duct at the time of tensioning. So there are two ways in friction loss. One is wave effect, or it is also called as Hubble effect, and the second one is curvature effect. So let us see what is wave effect. The interior surface of the duct has a sort of wavy surface which offers friction resistance. As the length of duct increases, friction resistance due to wave effect will also increase. So now let us see how to calculate the losses due to friction. So the losses due to friction can be calculated using the equation Fs into mu alpha plus Kx. So here mu is coefficient of friction between concrete and steel, which varies between 0.25 to 0.55. Alpha is the angle in radians through which the tangent to the cable profile has turned between any 2 points under consideration, and K is the frictional coefficient of wave effect, varies from 15 into 10 to the power of minus 4 to 50, and E is 2.7, and X is length between 0 chain edge and X chain edge.